Good morning, everyone. Today, we start with a new language. Hopefully, you have the opportunity to open your homework at least and start working. You notice, as usual, dynamic memory, arrays, and now solving a similar problem to the one that you solved before, but now with C++. So if you haven't done that, please start working as soon as possible so you can ask for help in case you need it. Remember, due date next week. Check Canvas for the specific. Moving forward, Lisp. Introduction to Lisp. Just to give the full view here. We finish with C++. As you notice, C++ in the middle point of object-oriented and structural programming. Why? Well, you notice a lot of things from C still work in C++. Your compiler, your development environment probably use the same compiler and everything to work with C or C++. You create classes or not. So below this picture, Java, the other language that you know that is fully object-oriented, and the big difference that you notice between this 100% object-oriented and this one in the middle is the main method. You remember the main is inside of a class for Java. Everything is a class. Every single method belongs to a class, even though you need to work with these static things to make that one main unique. C++, what you have is a combination of object-oriented when you need it, classes, methods, but your main is still a method outside of any class, which basically mean or represent a remembrance of structural programming, C. The main for C and for C++, when you look at them, they are similar. They are methods alone, outside of anything working. So we cover the family, C, C++, and you know Java as a prerequisite. Moving forward to the opposite side of the chart, we start today with Lisp. And I want you to notice the dates. We have been working with things from the 60s, the 80s, 90s, Java. And now we are going here. Moreover, we have been working with 3 languages that are highly connected, not only among them, but with others. A lot of programming languages are object-oriented or structural. And now we move to something that is a little bit isolated. Good news, even though this language here is kind of alone, the reality is that some of these languages, including Java, today include some concepts, and that means some elements, semantical rules, syntactical rules, elements in the language that come from this, the functional paradigm, and the implementation of those concepts in this Lisp language. That is the reason because we reviewed this language. It's not about you developing software in the future in a company using Lisp. The probabilities of that is not exactly high. However, understanding the ideas and how the things work there, you will notice that some new features in these languages, particularly Java, come from things that exist here. The main features in the functional paradigm. That is the reason because we're going to be working with this for a couple of weeks. So moving forward, Lisp. Usually there are the Lisp, the original one, called the common Lisp. And there is a flavor like that. I think in some classes, some courses, they use this one. We're going to work with the common Lisp. All the examples that I am going to show you all the links that I give you to get a virtual machine and interpreter for this are for the common Lisp version. Most of the things work the same in both flavors. We're covering the core elements. We are not moving to the elements that could be different, to the details. So we're working with Lisp, common Lisp. Key ideas, if you remember our lecture 3, when we was talking about the different paradigms and we start talking about the functional one, the key idea was, let's move up the level of abstraction. Let's make programming simple. Simple, higher abstraction. And I mentioned this example between math and coding, and in particular, coding with Java. If you think about math and Java, math, algebra is more abstract than Java, is more abstract than programming. Abstraction is about hiding the details, remember? Why I am telling you that math, algebra is more abstract than Java? Well, several different things. One, probably the most important right now, is I am telling you that math is most abstract because encapsulate details, in particular, details about the data. If you think about algebra, this is the only thing that worry you, your variables, your values, periods. When you're dealing with coding, and in particular with Java, C, C++, the first thing that you learn is you need to worry about, well, that X is going to be double, or the Y is going to be double, or they are going to be integers. And what is going to happen if we want to go from one to the other? We need to do some kind of casting, parsing. All this, for some people, is details. For some people, all this is complexity that can be avoided. Complexity that if we eliminate them, among other things, going up with abstractions, we can get a better language. And that is going to be the idea with this functional programming. Number one, higher abstraction means eliminate the data type. But you know what? Another thing that is complex here, and we can improve, well, some people think that we can improve, is, do you remember when you learned to program with Java and all this craziness about the curly bracket and the square bracket, and we still have the parentheses, and for some things in C, C++, we use the square brackets and so on. And that, besides the fact that we have the dot, and then we have commas for the parameters, but then we include the arrow and the scope resolution operator, all of this, delimiters. If you think about it, the only reason for all of this thing to exist is because we need delimiters. The dot between the object and the method, square bracket between the name of the array and the index, parentheses between the name of the method and the parameters, the comma to separate parameter. We can make this easier. What if we use only parentheses for everything? You mean to replace the curly brackets and the square brackets and this one and this one and this, only with parentheses for everything? In that way, you do not need to remember all of them. You can forget all of them. The only thing that you need to remember is parentheses. Everything that you need a delimiter, you use parentheses. For some people, that represents a simplification of the syntaxes. Simplification of the semantic, for instance, with the data types, simplification of the syntaxes, for instance, eliminate delimiters. Those are two key characteristics that we're going to notice working with the functional paradigm, two key characteristics that we're going to notice working with Lisp. Key idea, make programming simple. Simple because the semantic, simple because the syntaxes. Improving the level of abstraction, hiding the details. Okay, looks good. Checking this. In some point, lecture 3, several weeks ago, I showed you this and this. And something that I show you is, well, these two are the same program. This one is Lisp. This one could be Java, C, C++. Those words in kind of magenta thing, pink thing, they are the keywords. And you will notice what happened with the keywords and the size of the instructions. You will notice here, even though we need to work about the meaning of the program, but I want you to notice the size of the lines. I want you to notice, if I am telling you that these two programs are doing the same, notice the size, the number of elements in one and in the other. Particularly, if you search for data types, you're going to notice no data types. If you search for curly brackets, if you search for square brackets, you are going to notice they do not exist there. The only thing, parentheses. Easy to read or not? Well, that is something that you need to decide later when we review what is happening there. But syntaxes, simple, smaller. Delimiters, parentheses. Semantic, simple, no data types. And when you eliminate the data types, think about all these errors about type do not match. Think about all this casting that you usually do. They have no reason to exist. Everything can be anything. We need to go inside and understand this program, all the elements there. And that is what we're going to do today, the following weeks. Good? We are going to learn Lisp. Now, kind of moving forward, like your hello world with Lisp. Number one, I need you to remember that this one is a language that is going to work with an interpreter. From this point, Lisp and Prolog that is coming both work with interpreters, what we call it virtual machine with Java. Also, I need you to remember that both work with a virtual machine that basically do not have these fancy features that you found in Java. You work with something that line by line is running your program. Or instruction by instruction is running your program. Every single instruction is able to work together with the others coming, but every single instruction is going to show you or is able to show you a result because every single line is showing you a result. In a program in Lisp, the basic unit of a program is what we call it a list, and a list is something between parentheses. Lisp is list programming, the P programming, the list without the T, list. And we call it a list anything inside of parentheses. Okay. The first element after the parenthesis is open is the name of an instruction. An instruction. We're going to call more about that, but at this point you can think about a keyword, like the keywords in Java, or the name of a method that you are going to call from a library or something that you create, an instruction. In particular, all the instructions in Lisp are called functions. So the first element in this list is the name of the function that you want to call. We are back with this idea of functions like in C. Why they are called functions? Because something very, very simple. Functions, because they receive an input. Anything after the name of the function are considered parameters, and therefore the input for the function. Everything. We do not use comma. The parameters are separated, used by white spaces. Open parentheses, name of the instruction, the function, all the inputs. And the input, use something, space, something, space, something, and so on. Those are the inputs for the function. And it's a function because all of them are going to return a result. All of them are going to create a result. Key idea with Lisp, programming with lists, is your instructions are lists, are something inside of parentheses, name of the function, parameters, all of them return something. If you think about these being methods, all the methods here have a return internally. Examples. You can open your environment to program with Lisp, and you can write this. Open parentheses, name of the instruction. It could be a word or it could be a symbol. There is no limit here. What do you want to do? I want to do an addition. Okay, that is your instruction. That is the function ID plus. There is no operators here. The operators are functions. The methods are functions. The keywords are functions. What do you want to do is immediately after you open the parentheses, a plus. You want to add the 3 and the 2. You can put those two parameters, the 3 and the 2. You want to do 3 plus 2 plus 7. You put the plus only one time, and you can put the 3, the 2, and the 7. Oh, wait, I want to do 3 plus 2 plus 7 plus 9. You put the plus only one time, and all the numbers that you want as a parameter. Remember, simplification of the syntax? Simplification of the syntax. You do not need to repeat the operator. You put the operator one time, put all the values that you want to use with that operator. We need to talk about the overflow and underflow, but the answer is the virtual machine, the interpreter is going to take care of that. There is a limit, obviously, but in general, it's going to take care of that. So this is going to work better than Java, C, and C++ in terms of overflow and underflow. But we need to review some exceptions, so don't worry, we're going to talk more about it. Right now, my concern is the syntaxes. Syntaxes, open parentheses, closing parentheses, the instruction that could be keyword, method, operator, and then the parameters. The parameters that can be 1, 2, 3, whatever are needed. First program with the plus. Now, at this point, you can be thinking like, what happened with the main? Yeah, because every program have a main. Java have a main, C have a main, C++ have a main. we do not need a main here. The only thing that we need is to start writing instructions. So you can write this line number 1 and it works. You do not need this main, parentheses, curly bracket, blah, blah, blah. No need for that. Simplification of the syntaxes, remember. Put that line in your environment, click enter, and immediately the computer is going to show you this number. Every single function return a value. You can put that value in a variable. We're going to do that, don't worry. But always, 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 if you are running the program in kind of verbose mode, the computer is showing you what is happening in each of the instructions. So in this case, because I am not using variables, because I am not doing anything with that instruction, it's going to run the instruction like if that one alone in the main, and it's going to show me, well, what you put, your program, that could be the result. That is something that you're going to notice with Lisp. So this is one program in Lisp. Done. Another one. Open parentheses, closing parentheses, asterisk, multiplication. And I have integers, but also I have decimal values. I am going to talk more about the values, but you can do multiplication like that. Multiplication of two numbers, open parentheses, closing parentheses. You will notice that in Java, C++, the rule was a semicolon at the end. You put an instruction, semicolon at the end. The rule here, the semicolon do not exist for the instruction. Every single instruction go inside of parentheses. Always, always, always. Every single instruction. Open parentheses, closing parentheses. The semicolon. What do you think is the meaning of the semicolon in Lisp, looking at my example, the green color that I use? Yes. Java, comments or comments. Lisp, the beginning of a comment, the semicolon. Why the semicolon? Why not? We do not need semicolons. We use parentheses. Did you notice how the things change? Good. Now, obviously, there are instructions in Lisp. We need to review them that are not the operators that we know, plus or multiplication. There are these, for instance, one instruction subseq, and I can ask you to guess. And the only reason because I am putting this example is because this one receives as a parameter 1, 2, 3 things, and hopefully you notice the first one is a string. Yes, quotation mark are strings. Java, C, C++, also in Lisp is one string. This hello, comma, and word. This comma is part of my string. Again, you notice no commas to separate the parameters, no commas to separate the values. But I can use the comma as a character here. And the only reason because I put the comma is to show you that the comma exists as a character, but it's nothing related with the program itself. I have this parameter 1 is a string, parameter 2 and 3 are numbers. And can you guess what is this subseq instruction doing? What is the 2 and what is the 9? Hello world. The 2 is the character 2 in the string. 0, 1, 2, the L. And then the 9, you can guess is related with that one, right? Characters 2 to 9 in my string. Subseq is an instruction that is available in the language. We need to review more. And that instruction is to create a subsequence of characters. Given a string, give me the number in which I am going to start, the number in which I am going to end, and I give you a substring from the original string. We're going to review more. The only thing that I am showing you here is number 1, strings exist. Floating point numbers exist. Integer numbers exist. They are values. They can be used as a parameters. Number two, for operators, multiplications, you can do as usual. Addition, you can do as usual, but also you can do several operators together in only one instruction. That is fine. This is Lisp 1. Well, remember, the only thing that is doing the operator is the operation, in this case the addition, in this case the multiplication, and in this case, the only thing that is doing is extracting the information. The printing happens automatically for all the instructions. I haven't shown you yet the instruction for printing, that by the way is going to be print. But you are going to notice, again, all the instructions return a result, and the virtual machine, by default, print everything. So subseq extract the substring, period. The printing is happening just as the instruction before, by default, because the virtual machine print everything that receive as a result back. If you think about subseq is a method, and the method is returning a string, is returning an array of characters. The array of characters is printed because the virtual machine prints everything that receives back. So just careful with subseq is not an instruction for printing. The printing is happening automatically. Similar for the plus, similar for the multiplication. They are not print instructions, they are addition, multiplication. The printing happens automatically because the virtual machine. Good. Okay. Now, looks like simple, parentheses, no commas, and well, I can figure out that some of the operators that I already know are going to work. Some of the values that I already know are going to work. So things could be not so hard, hopefully. List processing, and hopefully now, question number 1 for your exam, what is a list in Lisp? And I need you to remember something inside parentheses. What is a function? A list in which this one is the function ID and all the other things are the parameters. We have an interpreter, virtual machine, quotation marks, and we are back with the idea of the virtual machine handling the memory. So no more deletes or mallocs or news. The virtual machine is going to work with the memory using the same way or better than Java. We can forget about the stack and the heap and where to put our data, because all that work, cleaning and storing things, are going to be handled by the virtual machine, the interpreter of the language. So we are back to the features that we enjoy working with Java and some extra features that we're going to be reviewing. You need a Lisp interpreter. I already shared this with you before in lecture 3. There are several different options. Maybe you get one of those at the beginning just to check what is happening. If not, now is the time in which I need to ask you as a homework, mandatory, you need an environment to work with the programs that we're going to be reviewing in Lisp. So different options. You can use any of this one. You can download the virtual machine, the interpreter running your computer, but there is always an option online. You can run your programs online, probably for Lisp, unless you want to have things locally. Most of the students, what they do is run the version online just because you don't need to install anything. You are going to notice that the environments to work with Lisp are not exactly as fancy as the ones that we use for Java, C, C++. You can try the option of a plugin. For instance, you can check for plugins for Eclipse or for other of the IDEs that you're using. Some of those have plugins that allow you to continue working with your environment and compile or run Lisp application. But again, this is something that is up to you. I need to tell you, if you need to use 10 hours in order to install a plugin or to install a virtual machine of Lisp, do not do that. This depends a lot of your previous experience. You know how to install a plugin with Eclipse or with your IDE, yes or no? If yes, you can easily go and search the plugin for Lisp. You are familiar installing software in your computer. You are familiar installing new software with Windows, with Mac, or whatever computer you're using. If yes, go ahead, get the new interpreter for Lisp, install locally. But if your computer is new, if you are starting using Mac or Windows, or if you do not have an idea what I am talking about with plugins, you're going to have the opportunity to learn about that later in a different class, in a different level. Right now, your time should be in learning the language. What I want you to do is learn the language. I mentioned this example before. You need to learn the language, like you need to learn Spanish, English, Chinese, whatever. It's great to have Microsoft Word to do your homework. Word helps you a lot to fix grammar or things, but it is not mandatory to have Microsoft Word in order to learn a new language, a new human language. So here, similar idea. What I need is you to learn the language, Lisp. If you can install a fancy IDE in your computer, great. But worst case scenario, instead of using 10 hours installing a piece of software in your computer, go and use this web page, open the web page, put your program there, click one run button there, and check if your program is running. If not running, check your program, check the syntaxes, check your knowledge of the language. Do not worry for the tool. That is my main advice here, guys, both for Lisp and for Prolog. Your goal is the language, not the compiler, not the interpreter in this case. In your exam, you are not going to use interpreters or compilers. You are going to show us that you know the language, the rules of the language, lexical, syntactical, and semantical. So, up to you. Worst case scenario, my advice, go for the online option. Can work perfectly well. Online option, I showed you the interface before. You can use copy-paste the lines from my slides all together or one by one. They are going to run. You are going to have the output there immediately. And as usual, copy-paste the instructions for every single slide that we review, and be sure that you understand what is happening. Moving forward, talking about the print instruction. Well, there are instructions for printing. Print. And open parentheses, the instruction, the parameters, closing parentheses. And as usual, print, you can have there a string, you can have there a variable. We need to talk about variables. You can have there a value that is going to be printed. Now, if you are using an interpreter locally in your computer, something that you're going to notice when you run this print whatever, you are going to have this as a result. You are going to notice that the output is the high 2 times on the screen. Can you tell me why? Can you explain that behavior? Because if I put +2 and 2, what I am going to have on the screen is the 4, only 1. Why with the print I am going to have 2? One, high, printed because that is the goal of the instruction. Second, print is an instruction. In any other language, print is void. In any other language, the print instruction do not return anything. The print instruction just put something on the screen. That is true with Java, with C, C++. In Lisp, as you mentioned in the chat, yes, the print instruction should return something. The rule in Lisp is every single function returns something. And if you're wondering what is going to be the return of a print, the same thing that I am printing. Print, return. The same thing that you ask print to print. So when you run a print locally in your interpreter, sometimes what is going to happen is you have two prints, 2 times the height. One, because it's the result of the instruction. The second one, because the interpreter, like here, is printing what the interpreter received back. This is particularly true and important if you are working with the virtual machine, the interpreter of Lisp locally in your computer. If you are using the one online, the good news is that for the online one, you have something like 2 panels. You have here your program and here your output. And in the web page, the only output that you are going to have is the output that you ask to be printed. All these messages, all the things that usually the interpreter do to the console are not sent to the web page. They are in the backend here. You never saw them. So for instance, this 4, it will be in your console if you are running the program locally. But if you run this program on the web version of the interpreter, you are not going to have this thing printed. What should you do if you want to print the result of this operation? Use an instruction to print, such as the instruction print. And what is going to be the parameter? What I want to print. Okay, this is the instruction, this is the parameter. They should be inside of parentheses. Parentheses, inside of parentheses, yeah. Which one is going to be executed first? The one that is inside. Therefore, the value of the parameter is going to be calculated first. This is going to be comma 4. And the instruction for printing is going to print that 4. Now you can have the 4 on the screen. Again, with the online. If you do this in a version local, what is going to happen is that you're going to have, just like before, 2 4s. The first one, that is the instruction print. The second one, because print is going to return the same thing that is printing. It's returning 4 because it's printing a 4. Makes sense? Obviously, you also have something like this, instructions that you can remember. SQRT was math.sqrt in Java. It was SQRT in C++, the method. Here is a keyword, SQRT, square root, and you pass your parameter, that is the number that you want to apply that operation. Okay, functions, parameters, everything returns something, and that something is printed by default by the virtual machine, or you can ask something to be printed explicitly with the instruction print. So far, hopefully easy. When I run this, it's going to look like this locally. This is one of the interpreters that I am asking you to use. You can notice, extremely simple. What you're going to have, this is the local version. You're going to have this cursor, and this is what you're going to have the opportunity to write, like the instruction, parentheses, print hello world. When you press enter, these results are going to appear, and you're going to be back to your cursor, so you can write another line. When you press enter, the result is going to appear. Here is a 4. And then you are back to your cursor and you can continue forever. There are options to create a file or open a file or save your file. That basically means that instead of writing line by line, you can have a file with all your lines and just open everything and all the lines are going to be executed. You're going to have all the results there in some place. Notice, copy, paste, and so on. The interface is very, very simple, really. It's like running a console. This can be easily be integrated with a plugin in your environments. But even as a plugin, your options are very, very limited. The online one is going to look like this. As you notice in the online, you are going to have this, that is the editor of your program. You can create your program there. In the online version, it's not running every line. The online version allows you to write your program like these lines there. And it's not going to run until you click run, just like in other languages. It's like you can work, put all your program together, several lines. And then when you're ready, you can click run, and run is going to show you in this panel the results. And as you can notice in my example, the only thing that is going to appear like results is those things that you print. Just like Java, C++, just check the console, things that you print are there, like I print hello world, but the result of 2 plus 2 is not there unless I ask to be printed with another instruction print. I think this is more clean if you are working with a long program. This is a good idea to start learning things and check line by line what is happening. Obviously, you can achieve similar results here. Just add prints to every single line that you create in this space, and you can debug in that way. Any option work. Obviously, the one that is better for you, but practice. This is the output of the simple things that I showed you before. Moving forward, we need something more complicated than this. Things that you are going to notice in my examples from this point and moving forward. Number one, the function ID, the thing that I put after the parentheses, that thing can be anything, symbol or words. Moreover, the combination of symbols that I can use is almost anything except the followings. I cannot use as a name for a function something that is the symbol parentheses. It's kind of obvious, right? I am going to use parentheses to enclose the full thing. So I cannot have a function with the name parentheses. It's not going to make any sense. I cannot use the quote. The quote is important because we're going to use the quote for a very particular thing later. So this one and this one are very, very important symbols in the language. We cannot have functions with that name, but there are others. This one, you can imagine the reason is the one that represents the beginning or the end of a string. So you cannot have a function that have as a name that one. And later, the back quote and the dot are going to be useful for other things. So you cannot have function with those names. But other than that, anything is possible. And if you compare this list with what you have in Java, C, and C++, that any function name should start with a dollar symbol, an underscore, or a letter. Did you notice that I didn't mention here the numbers? Are you telling me that I can have a number or as a name for a function, or a combination of number to something else, number at the beginning as a name for a function? Yes. And I am going to show you an example. The lexical rules are more simple, less restrictive. here than in the previous languages. Moreover, moving forward, something that is very, very common in Lisp is to use this symbol. If you remember in Java, when you have two words together, it's like 1 and 2. If you remember C and C++, the common thing to do was 1_2, everything lowercase. With Lisp, something that you are going to notice is that the style here is 1, and this guy is not a minus. It's a character. It's part of the word. Instead of using the underscore, it's very, very common in Lisp to use the hyphen. Just for you to remember when we review the examples. Now, something that you need to remember. No operators here. Everything is a function. When I show you the example with the asterisk or the plus, later with multiplication, division, percentage, and so on, they are functions, not operators. Functions. Yeah. Why? Because if you think about the plus as an operator, it's a plus b. But if you think about the plus as a function, it's a, b, c, d, e, and more. This is not an operator plus. It's a function with the name plus, and that function is going to do addition several times. Function, operator. In Lisp, everything function. You do not have access to the operator. Use like that alone. Finally, key thing, for the first time, we have a language that is case insensitive. Case insensitive, yeah, upper cases and lower cases are the same. The same, yeah. So I can have this one, square root, or I can have this one. It's the same, both work. Or I can do it's the same, both work. Work. This is important with the variables. Just remember, A and A now are the same. So we do not have this option to have the uppercase version and the lowercase version, or the name of the class with the S uppercase and the name of the object with everything lowercase, and they are different. Now, uppercase, lowercase doesn't matter. We need to find a different way to identify different variables or different version of things. All this is the same function, because the virtual machine is going to ignore letter by letter if they are upper or lower case. Anyway, functions. Let's talk about the parameters. Parameters. What can I use as a parameter of the different functions? What can I use as a parameter for the addition, multiplication, subsequence, print? What parameters are available? Well, usually your parameters are going to be your primitive data types. Well, here we do not have data types. What we have is atomic expressions, values. Values, important thing regarding values. Number one, negative numbers. I want to be clear with this, guys. In Java, C, and C++, what you have with -3 is one word with one element with two words. This is an operator, and this is the value. If you remember C, C++, and Java, minus unary is an operator, and that operator was before the 3, two words, two things. In a similar way, when you do this -x operator variable, in the other languages, the minus at the beginning with a number was a different word, an operator. Here in Lisp, this -3 is one word. The negative number is by itself one word. This minus is not an operation that is going to be done. The -3, the negative numbers in general, they are values that are valid in the language without the need of doing an operation. That is relevant. It's going to be minus. They exist as an atomic expression. They are not an operation that need to be done. Good. Okay, so far, fine. Are you telling me that now the negative numbers are primitive? Yeah. Second, you have floating point numbers. We don't care about float or double. You have floating point numbers. What does it mean? You put the dot. That is the reason because you cannot use the dot as an operator or as a name of a function. You have the dot, a number before, a number after. How long? As many digits as you need. How long here? As many digits as you need. Digits, dot, digits. That is a floating point number. No data type, so you can think about float or double. No limitation. Are you telling me that I can use as many digits as I want? Yeah, for instance, this one. What is that one? My line number 3 is an integer number. Can you work with that integer number in Java, C, C++? And I am sure that you're worried right now, like, that number is not going to work in my program. That number is going to give me an error. That number didn't fit in an integer, not in a long integer, not in a double, even if I am thinking about this 1.0. Good news. Lisp, you can use that number, no problem. It's going to work. In fact, in Java, you could use this number, but you need the class integer. You need to store this number in a linked list or some kind of data structure, and then you have functions that basically represent the operations. And in object-oriented, you can be working with these big integers, but you need to do the program to achieve that, or you need to use the library to achieve that. In Lisp, this use work. If the interpreter need to store this in an integer in the memory, in these 4 bytes, 8 bytes, it's going to do it. But if the interpreter need to create a full data structure in the heap, like a linked list or a vector, and a storage of these digits individually, and then need to do some kind of operation transformation in order to do the addition, multiplication, or whatever operation I do with this, that is something that is going to happen inside of the interpreter. That is something that you do not worry about as a developer. If you as a developer need a number like this, use the number. It's going to work. Do you remember factorial? Do you remember which is the highest number that you can use to calculate the factorial of a number? Can you calculate the factorial of 5, 6, 7, 8, 10, 100? I am sure that you remember that in Java, the factorial, calculate the factorial of a number, usually with small integers. When you start calculating factorial, for instance, the factorial of 100, your program crash, the virtual machine crash. We're going to work with factorial here. And I am going to ask you to compare Java versus Lisp. And you're going to notice, like you mentioned before, overloading or this Stack Overflow thing is not going to happen. This work. Moving forward, have you used complex numbers? Do you know what is a complex number? Help me. Complex numbers, what are they? Let me know if you know what they are or not. So yes, no, maybe. Yes, thank you. And what is the meaning of that? They are important in math. Okay, my point, guys. Complex numbers. You know what? In Lisp, complex numbers are part of the atomic expressions. Complex numbers are something that you have there in the language by default. You don't need a library to handle complex numbers. Are you telling me that if, for instance, I run an instruction like this in Lisp, I am asking for the square root, and this is use one number. Remember, there is no operator involved. I am asking for the square root of -1. Can I do that? Yeah. And what is going to be the result? Immediately, it's going to show you. That is the format of a complex number in Lisp. In Lisp, a complex number is going to start with the sharp. It's going to have the letter C. That represents complex number. And then you're going to have parentheses, again, parentheses for everything. And inside of the parentheses, you're going to have something, white space, something. Can you get what is that something, white space, something? Two things that you need for the complex number, right? The real part, the imaginary part. Two things inside of the parentheses. Sharp C, parentheses, one number, space, the other, a complex number. In my example, this sharp C 3.2 space 2 is something like a complex number 3.2 real plus 2, the imaginary part. They are part of the language. Look good. Moving forward. Similar to the minus. This guy, this, do not represent a division. That is not a division. If I want a division is parentheses, a division 2 and 3. This is an operation division. This is the operator, the function that represents a division. This one is one word. I need you to remember this in Java, C, and C++, 3 words: integer, operator, integer. Here, for Lisp, this is one word, and that word represents a fraction. A fraction, just like in math. In math, if you tell me that you want to do the addition of 1/2 and 1/2, this is what you do in Lisp. You want the addition, and this guy, they are values, 1/2, 1/2. The backslash do not represent in that point a division. The slash is the fraction, just like you do with math. So you are going to have sometimes results that are like this because the computer is going to give you that kind of results if you ask for something. For instance, you can ask parentheses, the division 1, 3, and the computer is going to play with you and is going to tell you, that is the result. My computer is not working because it's telling me the same that I asked. No, you ask for the division, the computer is telling you that is the result. A fraction of 1/3. This is an atomic value, the same that the complex number, the same that the long integer, the same that the floating point numbers or the negative integers. All of them atomic expressions, all of them basic values. Moving forward, characters. Do you remember that characters in the other languages are something like quotation mark, the letter, quotation mark? This is a character in all the languages that we have reviewed so far. But you know what? In this language, this symbol, the apostrophe, is going to have a particular responsibility that we're going to review later. So the apostrophe is going to be for something else. This single quotation mark is going to be useful, very, very useful for something else. We cannot use them. We cannot use it for characters. So we need to find a replacement of this. The replacement, the sharp and the backslash. Sharp backslash A is more or less what in other languages is A inside of these quotation marks. When you put these two symbols at the beginning, what you are representing is, okay, this letter is not the name of a function, is not a word, is one single character. And you can do the same with any character. Obviously, it works in the same way that before. When you want to use like the backslash, you put another one. This one is the character. You remember that you have the tab backslash T inside of the quotation marks. You remember that you have the backslash N inside of the quotation marks. You remember that tab, enter, they are characters. Here, they are characters also. Sharp, backslash, sharp, backslash, sharp, backslash. But instead of using only a letter, T, N, in Lisp, we use the full name. This is your character backslash T inside of quotation marks. This one is your friend backslash N inside of quotation marks. A white space inside of quotation marks, obviously something like this and nothing in the middle, the white space, the backslash, and the escape character. All of them have a representation before like this. Now they are a word, and instead of the quotation mark, the sharp and the backslash. Characters. Okay, characters, numbers. Good. Next. Strings. Strings, good news. They are almost the same that in the previous languages. For instance, hello world is still hello world. Dots, apostrophes, commas, all of them can be inside of a string, usually in the previous languages. If I want to put quotation marks inside of a string, just as before, I can use the backslash here, and that avoid that quote to close the string and allow me to have quotes inside of a string. If I want a backslash inside of a string, the only thing that you need to do is to use two. And with that, this guy is a character. You want the character in the string instead of some other extra functionality. Similar to the others, nothing new. Finally, true and false. Question in your exam. And this is a very common error. Hopefully you can take a note of this. In Lisp, the representation of true is the value T. That is the representation of true. Just like in C or C++ was the 1, and just like in Java was the keyword true. The keyword true do not exist in Lisp. True as a keyword, true as a value do not exist in Lisp. In Lisp you have T. In C++ you have 1, and in Java the keyword true. This true here. Professor, in your slide you put true. Semicolon, which means is a comment. I am putting there the comment that T is true. Makes sense? Second, if we need true, in Java you have false. Also, in Java, equivalent to the false in Java, in C and C++ was the 0, and for Lisp, false, of this idea of false. And also, we're going to review this, but the idea of null. In C and C++, for those two, we use the 0. In Lisp, we're going to have something called nil. Nil is the representation of both false and null. Null. Are you telling us that we're going to have some kind of null thing, which means pointers references? Something like that? We need to talk about it. And false, well, for the conditions. So, true, false, 0, 1, T, and nil. Question in your exam about some kind of operation, and that operation return T or nil. Those are the two options that are in the multiple choice question, or those are the two options, one of them that you need to write as an answer. Just for us to know that you remember that in Lisp, there is no true, there is no null or false, 0 or 1 do not represent Boolean values. Boolean values here, these two. And those are all the atomic expressions that we have in Lisp. Those are all the things that we can use as primitive values for the parameters. Boolean, string, characters, integer and floating points in all these different expressions. The only things that are new, fully new, complex numbers and fractions are atomic. Big numbers are available. Atomic expressions. Any questions until this point for Lisp? Good. Okay. See you next lecture. Thank you.